This is a continuation of the Chapter 12 review, starting with Problem 9. In Problem 9, we have a cylinder. It has a radius of 5 and a height of 11. So, first thing we're going to do is to find the lateral area. And lateral area of a cylinder, again, just like we did in 7, it is circumference times height, which is 2 pi r h, which is 2 pi, the radius is 5, and the height is 11. That gives us 110 pi, which is approximately 345.6. And now surface area is simply lateral area plus 2 bases, so it's 2 times area of the base. Area of the base is the area of a circle, so this is lateral area, and we're going to use the lateral area that we stored here in this calculation, plus 2 times pi r squared, the radius is 5, and that gives us lateral area plus 50 pi lateral area, and we're going to use the stored value, plus 157.1. This gives us an approximated value, 502.7. And that's problem 9. Now let's move on to problem 10. In problem 10, we're looking for lateral area and surface area of this regular pyramid. And because it's regular, all the side lengths are going to be congruent, and that therefore all these lateral faces are going to be congruent. So that makes our calculation fairly easy. So let's get started with this. For problem 10, lateral area is going to be the area of one of these triangles times 4. So that's going to be 1/2. That's little b, which is length of the base, times height. And this whole thing times 4, because there's 4 lateral faces. That gives us 1/2. Little b is 9, because that's the side length, times the height, which is the slant height of the triangular face or the pyramid. And that whole thing times 4. That gives us a lateral area of 144 square inches. And now we move on to surface area. Surface area is lateral area plus area of the base. We have one area of the base because pyramids only have one, just as cones do. Cylinders have 2, and prisms have 2. Following this through, we have 144 plus area of the base is the area of a square, so that's going to be 9 squared, and this gives us a total surface area of 225 square inches. So not too bad. Now problem 11. In problem 11, we have a cone. They give us the radius and they give us the height of the cone. So let's begin with lateral area. Problem 11, lateral area is, now this is the stranger of the formulas. Lateral area is pi r L. L being slant height of the cone. Now if you look carefully, you'll notice that they gave us the legs of this right triangle, and if you look even deeper, you can see that this is a 5, 12, 13 Pythagorean triple, and that means that this face is going to be 26. So it's 5 times 2 is 10, 12 times 2 is 24, and 13 times 2 is 26. If you didn't remember that, you could go ahead and use the Pythagorean theorem to find your slant height, which would end up being 24 squared plus 10 squared, and you would see that that's equal to 26. So let's go ahead and put our values in. That's pi, r is 10, and slant height is 26. That gives us 260 pi, which is approximately 816.8, and that's going to be square inches. Now for surface area, we have lateral area plus, again, one base, the area of the base, which is going to equal lateral area plus pi r, which is 10 squared. And that total value is going to be 1130.97, or you could round to 1131, depending on what the problem was asking for. So there's problem 11. Now let's move on to problem 12, which is going to be a regular polygon problem. Now problem 12 brings us back to some previous work that we did on areas of regular polygons, but not before we do the lateral area. Again, this is a regular polygon, so all these triangular faces are congruent, and they were nice enough to give us the length of the base and the slant height. So we've got everything we need to find the lateral area. Let's begin. For problem 12, lateral area is 1/2 base times height, which is the area of one triangle, and this is an octagonal pyramid because the base is a regular octagon. So we multiply this by 8. That gives us 1/2, the base is 6. The slant height is 10, which is the height of the triangle. And that whole thing times 8. This gives us 240 square feet. Now, let's do surface area. And surface area is lateral area plus area of the base. In this case, area of the base is going to be the area of this regular octagon. Now, they were really nice and gave us everything we need, so we don't really have to do a whole lot. Area of the base is the area of a regular octagon or a regular polygon, which is 1/2 pi. 1/2 perimeter times apothem, which is 1/2. Perimeter is going to be 6 times 8, because there's 8 sides. That's our perimeter. And our apothem they gave us as 3. So that gives us 72 square feet. So this gives us 240 plus 72, which is 3,112 square feet. Now I would like to note that I organize my work in vertical columns and I go from left to right, but I like to keep everything bracketed so that I know what I've done and I can trace my steps backward. You don't have to use this exact method, but it's important to organize your work carefully, because in these problems, especially in the more complex versions of problem 12, you're going to really need to keep things straight because there's lots of intermediate steps. So organization of your work is almost as important as memorizing your formulas. And good, strong skills in calculator usage to store your intermediate values and things of that nature. So let's go ahead and do problem 13. Problem 13 has us finding the lateral area and surface area of this composite solid. A composite solid is a solid made up of two or more other solids. So here we have a cylinder with a cone on the right end. And so let's first find the lateral area. So let's think about what lateral area is going to be. First, it's going to be the curved surface of this cylinder without the bases, and then it's going to be the nape of the cone, the curved surface of the cone without its base. Let's go ahead and get started with this. We have problem 13. Lateral area is going to be, now the lateral area of the cylinder is circumference times height or length plus the lateral area of the cone, which is pi r l. This becomes 2 pi r h plus pi r l. Go ahead and substitute in our values. We have 2 times pi times r, the radius is 3. The height or length of the cylinder is 12. Plus pi, r again is 3. And the slant height. Well, if you look in here, you see that this is a right triangle. This is a Pythagorean triple, the basic one, 3, 4, 5, right triangle. Again, if you forget that, you can always use the Pythagorean theorem. The slant height is going to be the square root of 3 squared plus 4 squared, which is going to come out to 5. So that's 5 here for slant height. And we put this in our calculator, and we get 72 pi plus 15 pi, which is 87 pi, or approximately 273.3 square centimeters. All right, now surface area. Surface area, let's give this a little bit of thought. We know that the surface area is going to be the lateral area plus a base. Now, it's going to be the area of this base because this is an exposed surface. Surface area is the area of all the exposed surfaces or the surfaces you could touch. This base is concealed. It's hidden by the cone. So we're not going to include this circle for our surface area calculation. So what we have here in this composite is lateral area plus area of the base, only one base. That gives us lateral area plus pi, r is 3 squared. And that gives us a composite area of 301.6 square centimeters. So a pretty straightforward problem there. Let's move on to problem 14, and it looks like we're going to do that at the beginning of the next video. So I will talk to you in the next video.